All right, that leads us into now what the formal definition of the derivative function is. Okay, derivative function, we have different notation for it. If our function is, if we're told y is equal to, we use the notation dy dx, the derivative of y with respect to x. It tells you the variables, all right? Now, the derivative describes the gradient of the tangent. So it's the gradient of the line or the tangent of the function. It's the rate of change of the function. If we're going to use f dash of x, it's because our function is called f of x. The process is differentiation. All right. Now, for functions of the form, again, my printout is a bit skew if. So all that says, if we have a function f of x equal to some polynomial type of rule, n can be positive number, negative number, fractional number. All it means is if f of x is equal to that, that means that the derivative of that function is given by multiply by the power and then take 1 from the power. Okay, it's a straightforward process. All right. So in here, if we look at our examples now, rewrite the rule so you know what the power of everything is. Square root of x, that's x to the power of a half. Something over x, that's the same as minus 3x to the minus a half. 1 on x, that's x to the minus 1. So now I've got y, so the derivative function dy dx, you have to use the notation. Okay, 2 times 2 is 4, x, take 1 from the power. A half comes out the front. Take 1 from the power, a half minus 1 is negative a half. Negative a half times negative 3 is positive 3 on 2x. Negative a half minus 1 is negative 3 on 2. Negative 1 times x is minus x. Minus 1 is minus 2. So that's my derivative there. Now, it's quite possible that we might try and tidy it up so everything is in a positive index. So we'll have 4x, x to the minus a half might be 1 over 2 square root of x plus 3 over 2. Now we could write it as a range, but we might just write it as, it could be the cube root of x squared, okay, and minus 1 over x squared, all right? So, look, that's our answer. But you need to be aware that maybe in a, well, actually, if it was a multiple choice, the calculator would probably give you that form. You've just got to be aware of the different forms the answer could take, all right? What about the second example? This case here, whilst we will come up with different rules, if you remember from last year, chain rule, product rule, quotient rule. Quotient is a division, but if we can split this one up, we can write that as 2x cubed over, now the square root of x cubed, let's put that as x cubed to the power of a half plus x over x cubed to the power of a half. Let's simplify that a fraction first. So we've got 2x cubed over x, the half multiplies through. All right, and now our index laws, they're the same base, so we subtract the powers because it's division. So x to the 3 minus 3 on 2, that's 6 on 2 minus 3 on 2, so that becomes 2x to the positive 3 on 2. I've got plus x to the 1 minus x to the 3 on 2, so that becomes x to the minus a half, all right? Therefore, my derivative function dy dx is equal to, what do we have to do? Multiply by the power, so it's 3 on 2 times 2x, take 1 from the power, so it's a half, minus a half times x, take 1 from the power, negative a half minus 1 is minus 3 on 2. So negative a half minus 1 equals negative 3 on 2. And I can promise us, boys, that's what we'll get wrong. It'll be our fractions that we'll get wrong, won't be our calculus. So 2 times 3 is 6, divided by 2 is 3. So we'll just write it as 3x to the half minus 1 half. We'll just leave it as that, x to the minus 3 on 2. All right? So just step at a time. A little application of it. So we've got a curve there, all right? And it has a gradient of negative 5 at the point 2, negative 2. Find the values of a and b. So we've got two unknowns. I need 2 bits of information. There's one piece of information, because when x is 2, y is negative 2. So let's substitute that in. So y is negative 2, x is 2. So we get a times 2 squared plus b over 2. Therefore, we get negative 2 is equal to 4a plus a half b. So there's equation 1. What about equation 2? What information? It says the gradient is negative 5. So the key is there. That means at x equal to negative 5, the gradient, or dy dx, is equal to, oh shit, sorry, that's not right. The gradient is negative 5. So let's go back a fraction. Let's rub out that, because that's not what x is at all. It's saying that at x equal to 2, the gradient, or the dy dx, is equal to negative 5. All right, so first things first, let's find dy dx. So if y equals ax squared plus bx to the minus 1, let's find the derivative. Dy dx is equal to 2a, take 1 from the power, plus negative 1 times b is minus bx, take 1 from the power. That's what the derivative is. All right. So at x equal to 2, dy dx equals negative 5. So negative 5 is equal to 2a times 2 minus b times 2 to the minus 2. Simplify that. 2 times 2 is 4a. 2 to the minus 2 is 1 over 2 squared, which is 1 over 4, minus 1/4 of b. So there's my second equation. All right. So let's bring those together. I get negative 2 equals 4a plus a half b. And the other equation is negative 5 equals 4a minus 1/4 b. So the a's are the same coefficient. So let's subtract them. So what am I going to do? Oh, we'll do top minus bottom. So we get, what do we get? We get minus 2 minus 5. So minus 2 minus a minus is plus. So negative 2 plus 5 is 3. 4a minus 4a is 0. A half minus 1/4 is 3/4. Yeah. So then 4 3s are 12 is equal to 3b. So b is equal to 4. So I might just substitute that in here. So I get negative 2 is equal to 4a plus a half of 4, which is 2. Subtract 2. Negative 4 equals 4a. A equals negative 1. Find the values of a and b. So let's just highlight them. A equals negative 1. B equals 4. All right. So a couple of things in that. The process of doing the derivative, multiply by the power, then subtract from the power, all right, especially with our polynomial. And more importantly, and the biggest thing for us, okay, What does the derivative give us? The derivative is the gradient. So whenever you see a question that talks about the gradient, the tangent, the rate of change when we get to it, the maximum, the minimum, it all means the derivative. All right, off you go.